Now, this is going to be a very small session. I am going to teach you FM transmitter and receiver with block diagrams. FM transmitter and receiver is a very important topic and very commonly asked in question papers. You need to explain an FM transmitter and an FM receiver with the help of supporting block diagrams. So this is a basic block diagram of an FM transmitter. When it is a transmitter, you have a microphone with a reactance modulator, master oscillator, buffer amplifier, limiter, RF power amplifier. From here you have a mixer. Here you are generating the carrier signal using a crystal oscillator with a mixer, IF amplifier, phase discriminator given as an input to the reactance modulator, and this amplified signal is transmitted to the receiver. So this is a basic block diagram of an FM transmitter. I'm going to explain to you the functions of each block in the coming slides. Every block has a purpose. We'll see what is the need for every block and how a frequency modulated signal is being generated using our basic electronic circuitry. The output of the discriminator is connected to the reactance modulator and provides the voltage to correct automatically any drift in the average frequency of the master oscillator. So let us draw the block diagram of a FM receiver also. After this, I will give you a detailed explanation of how an FM signal is generated and received. In order to understand how a transmitter and a receiver works, we have some concepts in frequency modulation which we will be studying in detail. So this particular receiver, the block diagram whatever is shown, is known as super heterodyne receiver. It consists of an RF power amplifier, mixer, IF amplifier, limiter, discriminator, de-emphasis network, AF amplifier, AFC, and local oscillator. There was a very common question that there is a very common question that is being common that is asked in your exams. What is the need for this pre-emphasis and de-emphasis network in frequency modulation? The incoming signal voltage in a receiver is combined with the signal that is being generated in the receiver. There is a local oscillator that generates the signal. This local oscillator voltage is normally converted into a signal of low frequency. The signal at this intermediate frequency contains the same modulation as the original carrier, and it is now amplified and detected to produce the original information. A constant frequency difference is maintained between the local oscillator and the RF circuit, normally through a capacitance tuning, in which all the capacitors are ganged together and operated in a unison by one control knob. We have a group of capacitors that is being used for tuning and setting up a radio frequency, intermediate frequency, to receive the signals which we, the signals that only we require. Okay, so this frequency which stands in between the frequency band is known as intermediate frequency, and this particular frequency which is available, which is in the center of this band, is picked up and amplified. The IF amplifier generally uses 2 or 3 transformers, each consisting of a pair of mutually coupled tuned circuits. We use a transformer to amplify the intermediate frequency that is being received. The IF amplifier provides most of the gain and bandwidth requirements for the receiver. So one of the most important components of a frequency FM receiver is the IF amplifier.